Welcome back to Djji Tutorials. Today we are covering graphs and transformations of trigonometric functions. Let's dive in. Graphs of trigonometric functions. A periodic function repeats its values at regular intervals, meaning it exhibits a repeating pattern. The length of one complete repeating pattern is called the period, and the function is said to be periodic with that period. Key aspects of a periodic function include repeating pattern. The function's output values repeat in a predictable way over time or with respect to its input. Period, the smallest interval over which the function completes one full cycle of its repeating pattern. Amplitude, the height of the function from its minimum to its maximum value, or the distance from the function's center line to either its peak or trough. Frequency, the number of cycles a periodic function completes within a specific time or distance. Examples of periodic functions include trigonometric functions like sine, cosine, and tangent. These functions repeat their values over specific intervals of radians. Waves, sound waves, light waves, and other waves are often modeled using periodic functions. Oscillations. The motion of a pendulum or a spring is often described by periodic functions. Mathematically, a function f(x) is periodic with period t if f(x plus t equals f(x) for all values of x. This means that if you shift the function's graph by the period t, the graph will appear identical to the original. The graph of y equals sin x is a sinusoidal wave that oscillates between -1 and 1, repeating its shape every 2 pi units. Its domain is all real numbers, and its range is from -1 to 1. The graph is symmetric about the origin, meaning sin of -x equals sin of x. Key features of the graph include amplitude. The amplitude of the sine function is 1, meaning the maximum value is 1 and the minimum value is -1. Period. The period of the sine function is 2 pi, meaning the graph repeats its shape every 2 pi units. Midline. The midline of the sine function is y equals 0, which is the x-axis. Symmetry. The graph is symmetric about the origin and has periodic symmetry with a period of 2 pi. Key points. Key points on the graph include 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and 2 pi, 0. The graph of y equals sin x is a continuous, smooth curve that does not have any sharp corners. It is a fundamental function in trigonometry, and is used to model many periodic phenomena in physics, engineering, and other fields. Transforming graphs of trigonometric functions involves manipulating the basic sine, cosine, tangent, etc. curves through shifts, stretches, and reflections which can be represented by changes to their amplitude, period, and phase shift. These transformations alter the graph's height, width, and position on the coordinate plane. Here's a breakdown of common transformations. 1. Vertical shifts, midline changes. Adding a constant to the function shifts the graph vertically. 1. Horizontal shifts, phase shift. Adding a constant inside the function, within the argument of the trigonometric function, shifts the graph horizontally. 1. Vertical stretches, compressions, amplitude changes. Multiplying the entire function by a constant stretches or compresses it vertically. 1. Horizontal stretches, compressions, period changes. Multiplying the argument of the trigonometric function by a constant stretches or compresses it horizontally, affecting the period. 1. Reflections. Multiplying the function by -1 reflects the graph across the x-axis. Hope you find this video useful. Please share and don't forget to like and subscribe.